Hello, my name is Vikas Sinha. This is a presentation of the project that I did as part of the final exam for the Data 605 Computational Mathematics course at the City University of New York. The aim of this project is to implement a multiple regression model to predict housing prices. The data set that is provided is downloadable from Kaggle, and it is the mass data set. The model is implemented here using the training data that is provided, and then the test data is also downloaded later, and the model's predictions are then scored against the test data. The model's predictions, are produced using the test data and submitted to Kaggle in the form of a CSV file that has all the results that are produced by the prediction model. So I will be describing what I did as part of this, which includes selecting the model, fine-tuning the parameters, summarizing and analyzing the results, and then what was needed in order to submit the model to Kaggle. So at this point, the entire training data set has been loaded into a data frame that is called df. As you will see in the screen, the variable df is used here without any prior history. That is because the variable has already been initialized with the training data set. The training data set happens to contain 81 columns and 1,460 rows. The 81 columns represent 80 potentially predictor variables and one target variable, which is the sale price. So the object here is to implement a model that uses multiple regression and uses as input the variables that are available in the training data set. So I started by looking at the description of the training data set, which is the train.csv file, and looking at the meanings of the variables and the descriptions that are provided there. And then I just, based on my intuitive understanding of which variables were relevant to housing prices, I selected a number of variables that could potentially be predictors, potentially having a good correlation with the target variable. So I selected about 36 variables, as you can see here, and I removed some that had some did not have good values or had a large number of NAs in them. So the next thing is to just use the LM function to create a model, and after doing that, then I print the model summary, and the summary shows, as you can see, all the variables with their coefficients and their associated p-values. So you see a large number of variables that have p-values indicating that they are not significant. In other words, p-values that are higher, and some variables that are marked with asterisks showing that those are related, have a good correlation with the target sale price. Looking at the adjusted R-squared value, it is almost 0.85, which is very good. It implies obviously that about 85% of the variation in the data is explained by this model. The overall p-value is very, very low, which is good, which means that the model has a good correlation overall, good prediction overall. However, the problem here that we see is that the degrees of freedom are very much lower compared to the number of observations in the data set. And that right below that, we see the reason for that is that a very high number of observations were deleted because they had missing values. So looking at the histogram of residuals here with this model as it stands, see the histogram of residuals looks very good, looks like a normal distribution. looking at the fitted versus the residual values, there is no clear trend here, which is good. It looks like there is no pattern here, at least no pattern that I can see here, which is usually is a good indicator. Looking at the QQ plot, we see that it is almost a straight line except for some low and high values. So that overall again looks very good. But as I said earlier, there were a large number of missing values, and we should do something about them, because that means that we are not fully using the entire training data set. So for that, I do a summary on the data set, and I look at each variable's NA values or NA count that is reported, and I found that the variable fence had a very large number of NAs exceeding 1,000, and the variable fireplace quality had almost 700 NAs. So accordingly, I dropped these variables from my model and then ran the regression again, or trained the regression again. So I use the dplyr select to drop certain variables, and this is a convenient way to do the model without having to type out all the variables with the tilde and the plus signs that are usually done. I find this form slightly more convenient to work with. So with the variables that had large NA values removed, looking at the summary of the model, we see that the adjusted R-squared value is still high, almost the same as before, but it has reduced by a very small amount. The p-value is still quite good, and we have much higher degrees of freedom. Obviously, that was because we removed some variables that had missing values, and that made more of the dataset's observations usable and accessible to the training model. Looking at the p-values of the variables, we find that a number of them have asterisk indicated, which means that those p-values are below the level significance, and which means that there is a strong correlation with those variables. So we look at the histogram of residuals then, and we find that it has changed a bit. The tails have increased. There is left skewness and right skewness as a result of dropping those observations that we did. Looking at the fitted versus residuals, I cannot see any clear trend here, although it does look like for large values we see some potentially some outliers. Looking at the QQ plot, this has changed again. This indicates that there's a heavy tail at both ends of the distribution. This is not exactly a normal distribution at this point. So now again, I looked at the model and looked at the variables that were not significant to the prediction, and I looked at variables that fell in that category and created another version of the model that with those variables removed. So there were 4 of those: the roof style foundation, the basement condition, and the miscellaneous value. With those variables removed, I ran the regression again a third time, and this time getting almost the same result as before. The histogram looks the same, of residuals looks the same as before, as just the prior version. The residuals, the fitted versus the residuals, I am not seeing a clear trend that I can see. And the normal and the QQ plot shows that there's a heavy tail in this model at both the very high values and very low values. At this point, I then went ahead and created the submission file, created the file of predictions based on the test data. Kaggle requires for this computation that the data should be in the form, the submission should be in the form of a CSV file containing the predictions. So the rest of this is an attempt to produce the CSV file in the desired format, which was actually less than trivial for me because I was doing this for the very first time. I found that there were a large number of NAs that were in the data set. And because of that, Kaggle would not accept the data set, would not accept the CSV file containing the predictions, again, because the predictions had a lot of NAs. So then I removed those NAs by replacing them with the mean of the predictions in order to just be able to submit to Kaggle. So as you can see, that the last few lines of code achieved that by replacing the NA predictions with the mean of the predictions, and then the rest is simply creating a submission file that is then uploaded into Kaggle. That is the end of this presentation. Hope it was useful. Thank you.